So here you want to figure out how to calculate the rate of a dopamine drip to give. And you said that you were having problems understanding the book calculation and the clock method. So I don't know if you've ever heard of dimensional analysis, but we can use that same method that they use in chemistry for solving these problems in a medical sense. So you are given that you have a dopamine. You're ordered to administer dopamine at 5 micrograms per kilogram per minute. Okay, per minute. So what you can do here, and your patient weighs 155 pounds, so 155 pounds. So what we need to do is convert this pounds to kilograms, which is relatively simple if you work at it a bit. So what we want to do is to convert from pounds to kilograms is realize that there's a conversion factor of 2.2. Okay, so what we do is just take 155 and divide that by 2.2. And here I'll kind of cheat and use a calculator, but that's approximately 70 kilograms, okay? 70 kilograms. So we'll need that for the rest. And what you can do actually is you can round up. So another easier way to do this when you're kind of in the heat of things is you can round up. So you could go 150 or 160 divided by 2, which gives you 80. Now what you want to do is, yeah, we can use that. So, and actually move the decimal place over. So for example, if you have 160 divided by 2, which is equal to 80, we know that there's a 2 in the 10th place, so what we do is just move this decimal place over right here, move it over, move the decimal place over right here, and subtract 8 from 80. So if we subtract 8 from 80, we get 72. Okay, so we get 72, which is definitely close to 70. Definitely close to 70. So that's another way of doing it. If you are a little bit confused about that, I can definitely show you more in depth of this calculation. But basically what you want to do here is divide 160 divided by 2, which is 80, and then move the decimal place over one place and subtract 8 from 80. Hopefully that makes sense and it's a little intuitive. But anyway, so we have a 70 kilogram patient. Okay, so what we can do is, as I explained before, a little bit of dimensional analysis. So we have 5 micrograms per kilogram. So here I'm not going to worry about the minutes just yet because we want the rate. So I'm not even going to include the minutes there. So we have 5 micrograms per kilogram, and we're going to times that by that patient's weight, 70 kilograms. And here what you can do is you see these cancel out, and that will equal, what is 70 times 5? Well, that is 35 micrograms. And here this is where I'll bring back the minutes, because the minutes is still per, which is, it means that it's on the bottom. So 350 micrograms. 350 micrograms per minute. And obviously this is a rate because you have an amount over a time value. So whenever you have, let's say, whatever it may be, x over some time t, that gives you a rate. Okay. So for example, when you're thinking about a car, you have miles per hour. This is a rate. This is a rate, okay? Let's think of another rate, okay? Let's say if you like physics, meters per second. That's another rate because you have a time on the volume, on the bottom, I'm sorry. So this is pretty much how you would work that using dimensional analysis. So you have 350 micrograms per minute. Alright, so just walking you through the steps. So we did 5 micrograms per kilogram per minute. We converted the patient's weight to kilograms. Then we used dimensional analysis here in order to figure out what the rate was.